Okay, so no homework. Hey, just a reminder for those who did poorly on the test, make sure you send me an email. Take a retake. Take a retake. All right, so we're going to start chapter 11. It'll be the final chapter of the year that we get through. Here's your homework. I think I made a mistake. I started at 2 through 20. Probably meant 1 through 20 all, but let's just do 2 through 20 all. We'll be okay. Okay, so we're going to start off with something called property of rational numbers. This is sort of a repeat of what we did in pre-algebra. Remember when we talk about numbers and groups of numbers? So when we talk about the first set of numbers, we talk about those numbers that caveman, cavewoman used, right? They could count 1 rock, 2 rock, 3 rocks. They didn't have fractions, they didn't have decimals, they didn't have negative numbers, they didn't even have 0. We call these groups of numbers the natural numbers. Along came many civilizations. They came up with the idea of 0. If you add 0 to the natural numbers, we get the next set of numbers. Once again, still doesn't contain negatives or fractions or decimals. We call these the whole numbers. So it's kind of like you add 0, you've got a whole complete set of numbers. Now, when we think about the positive numbers, the negative numbers, and 0, remember 0 is neither positive or negative, we get the group called the integers. But there's a whole nother infinite set of numbers that are between the integers, like between -2 and -1, or between 0 and 1, or 2 and 3. Those are our fractions and decimals. We call those numbers the rational numbers. So write this down, please. The definition of a rational numbers, remember these are the decimals and fractions. These are the numbers that can be expressed as a quotient. A quotient is a fancy name for the word fraction. However, it further adds that those two numbers must be integers, meaning the numerator and the denominator, in other words, a and b, if we just talk about any fraction, must be an integer. Further, remember we can never divide by 0, so b cannot be 0. So this is straight up, this is high-level math here. This isn't the definition I gave you in pre-algebra. It's not the definition I use in course 1 either. But this is the algebra one, and further this is as stringent as it gets. So a rational number is a number that can be expressed as a quotient, a fraction. That's a comparison of two numbers using division. That's what the fraction bar means, division. Where both numbers are integers, that means they can be positive, negative. It also means they could be 0, and we have to add that one exception, b cannot be 0. In other words, you can't divide by 0. Okay, so those are the rational numbers. For instance, 5, even though it doesn't look like a fraction, quotient, fancy word for that, it can be written as 5 over 1, so therefore even that number is a rational number. Classically, fractions come in 3 different forms. You've got your standard, we call this the proper fraction. That's where the numerator, the top number, is smaller than the denominator. We have improper fractions. That's where the numerator, the top number, is bigger or larger than the small number. And then lastly, we have mixed numbers. That's a combination of integer and a proper fraction. So we have 5, it could be -5, 5 and 3/4. Okay, so negative rational numbers, I've said this many times in this class, remember it can be written 3 ways. The negative can go in the middle, the negative can go on the numerator, and the negative can go on the denominator. So if the fraction is negative, those are the 3 ways that you can write it. You cannot write it this way. That's a positive fraction right there. Negative divided by negative is a positive. So even though that is a fraction and it appears to be negative, it's actually positive. The top 3 are how we write a negative fraction. And generally, the first way, the one on the left there, -3/4, negative in the middle is how you write it. You'll see in algebra that, and we've seen it this year, that sometimes it makes sense to write the negative on the top or the bottom. Another idea. So we know that 4, which is an integer, can also be written as 6 minus 2. So an integer has many different ways to be expressed. Well, we can say the same thing about fractions. Way back when you first learned about fractions, one thing, remember fractions are rational number, your teacher had you make what's called an equivalent fraction, right? 3/12 is literally 1/4. It just hasn't been reduced, so is 5/20. So rational numbers can come in different forms. All right, here's the first skill we're going to talk about. We're going to convert numbers into fractions, into rational numbers. So I'm going to give you either an integer, I'm going to give you a mixed number, I'm going to give you a percent, or I'm going to give you a decimal, and you are going to write them as a fraction. Okay, let's see how that works. So like I said, I'm going to give you an integer, 3. How do we write 3 as a fraction? That's the easy one. You just put it over 1. Okay. How do you write negative 2 4/5 as a fraction, like an improper fraction? Remember the clock method? You take the 2, you multiply it by the 5, you add the 4. 2 times 5 is 10, plus 4 is 14. Now, we don't multiply negative 2 times 5. We ignore the negative. We just plug the negative in at the very end. So 2 times 5 is 10, plus 4 is 14, 14 over 5, and we add the negative, so negative 14/5. Percents. Remember, percent is a number in relationship to 100. So we simply write 18 over 100. So you write the percent as the numerator. You always put it over 100 and then reduce the fraction. Okay, 9 over 50. Decimals, remember the easiest way to change a decimal to a fraction is simply to write what's to the right of the decimal as the numerator, and then the 6 is in the tenths place, so 6 over 10. Okay, we look at the last digit and see what number it is. You could also say that it only has one decimal place, so add 1 0, so 6 over 1 and 1 0, 6 over 10. We do have to reduce those, so 3/10. This is all stuff that we did last year. All right, let's see this again. Negative 10, we simply put negative 10 over 1. 3 and 3 sevenths. Let's see, 3 times 7 is 21, plus 3 is 24, so we get 24 over 7. 40% would be 40 over 100, right? We simply write 40 over 100, we reduce. And lastly, negative 0.23 is 23. The 3 is in the hundredths place, so 23 over 100, or there's 2 decimal places, so you add 2 0. Those are the 2 ways that I look at it. A quick note, if you have a whole number and a decimal, or integer and a decimal, so like, for instance, 6.23, here's how that's done. Well, this can be written as a mixed number, right? 6 and 23 over 100. The 3 is in the hundredths place, right? And then we can convert that into an improper fraction. 6 times 100 is 600, plus 23 is 623. Also note, all right, do box number 3. This is the next question on the Google Forms. Get all 4 answers, write those in the Google form, and then play and see what you get. All right, 0 over 1. Remember, we can't divide by 0, but we can put 0 on the numerator. So 0 over 1 is how you write 0 as a fraction. Negative 2 2/5. Let's see, 5 times 2, or 2 times 5 is 10, plus 2 is 12. So we get negative 12/5. 4.6 over 100. Move the decimal place once for top and bottom. So 46, we got to reduce that. When in doubt, just reduce by 2 if both of them are even numbers. So 23 over 500, and that turns out to be the answer. And the last one, would be 5 and 1/10. 5 times 10 is 50, plus 1 is 51 over 10. There you go. All right, they're going to ask you to compare rational numbers tonight for homework. They're going to ask you to compare 2 fractions. Therefore, you'll use either they're equal or less than or greater than. And they'll also ask you to put the numbers from least to greatest. So you will have to compare these numbers. All right, so let me give you 2 numbers. And, well, obviously, that's pretty easy to see what symbol we use. Remember, when things are negative, the larger the number, the smaller the value. 10 is not bigger than 6. But negative 10, right? I said that backwards. 10 is bigger than 6. However, negative 10 is not bigger than negative 6, right? Negative 10 is to the left on a number line of negative 6. And remember, as we go to the left on a number line, the numbers get smaller in value. I mean, technically the numbers are getting bigger, right? 10 is bigger than 6, but negative 10 is not bigger than negative 6. Okay. All right, easy. So comparing rational numbers, fractions, well, we got to look at denominators, right? We need to have common denominators. For instance, if I give you 2 fractions and ask you equal, less than, or greater than, I don't know, because they don't have common denominators. So there are 2 techniques. Technique number 1, common denominators. What's the common denominator? Common denominator of 3 and 7. That would be 21. So let's say we multiply that first fraction top and bottom by 7. And the second fraction top and bottom by 3, and therefore we can see that since 56 is bigger than 51, that is the symbol. Makes sense, right? But we do have to get common denominators. I'm going to teach you another technique. It is optional, but it's pretty slick. This is called comparing the means and extremes. This is how it works, okay? I'm going to give you two fractions here. Well, here are two that are equal, right? Notice when two fractions or ratios are equal, we have this thing called cross multiplication, where the cross products, the means and the extremes, are equal. 1 times 6 is the same as 3 times 2. That's what happens when they're equal, right? So in other words, A times D, right, is equal to B times C. Well, what happens when they're not equal? Like, look in the yellow there, they're not equal, right? What would that mean? Well, we still have cross products, right? That would mean that A times D would be bigger than B times C. See what I did there? All I did was the cross products and threw in the greater than symbol. I used the greater than symbol because that's what I was given. What would happen if it would be less than? Same thing. A times D would be less than B times C. It turns out this is an easier way to compare fractions than getting common denominators. Let me show that to you. Okay, check this out. Okay, I'm going to compare the means and extremes. Well, on the top there, we already knew what the answer was because we got common denominators, but let's see how this works. Multiply 8 times 7. That's the cross product, right? Well, 8 times 7 is 56. Multiply 3 times 17. That's the second cross product. Well, that's 51. Notice that numbers match what's in the numerator. That's what will happen. So you don't need to get common denominators. You simply need to multiply the means and extremes to compare two fractions. If that was too quick, let me show you one example before you rewind. All right, let's say I need to compare those two fractions. We simply do the cross products. 4 times 18, that's the first cross. That would be 72. 11 times 7, that would be you have to do these in the right order. So it's the top left times the bottom right, and that's on the left side. Then the bottom left times the top right, that's what's on the right side. Now, which one's bigger, 72 or 77? Well, clearly 77. Therefore, 7/18 is bigger. Hey, that's a little bit easier than getting common denominators, right? Saves us one step. All right, so let's do a couple. All right, so I'm going to use this using the means and extremes. I'm going to do the cross products. Remember, top left times bottom right. 4 times 8 is 32. Bottom left times top right. 7 times 3 is 21. Which one's bigger? 32. Therefore, 4/7 is bigger. All right, bottom one. 7 times 5 is 35. Now it was negative. 4 times 9 is 36. It's negative, because remember the fraction originally was negative. Which one's bigger? Negative 35. Therefore, that fraction is greater than. You see how that works? All right, now if you want to rewind the video if you need to see those examples again. If not, go ahead and do these two all by yourself. Oh, I forgot to state also, write the answer in Google Forms. How'd you do? Well, let's see. 5 times 4 is 20. 8 times 3 is 24. 24 is bigger, right? Therefore, the greater than points to the 3/4. 9 times 3 is 27, but it would be negative. 2 times 13 is 26. It would be negative. Negative 26 is bigger. Therefore, 13/3 is bigger. That's pretty slick. All right, last thing. This is brand new. You have not done this. I'm going to give you two fractions, right? And you're going to figure out what's in between the two. Give me a number that's halfway between the two fractions. Remember, numbers are infinite. And between any two numbers, there's an infinite number of numbers, like mind blown. Right? So rational numbers are infinite, and between any two rational numbers, that means between any two fractions, there's another infinite set of numbers. All right, so how do I find these fractions? Well, I'll show you how to find one of them at least. Here's the game. I'm going to give you two fractions, and you're going to tell me what is between those two fractions, like what's halfway between 3/4 and 5/6. Okay? Here's the best technique. The best technique, well, let's just think about easier numbers like, I don't know, 6 and 8. What's between 6 and 8? Halfway? 7, right? Well, how did you figure that out? Well, mathematically, 6 plus 8 is 14, and 14 divided by 2, that would be halfway, is 7. And we're going to do the same thing with those fractions. So the technique is to add the two fractions together, common denominators, and then take half. In other words, multiply by 1/2. Okay, so we do have to get common denominators. So the common denominator there is 12, top and bottom of the first fraction times 3, top and bottom of the second fraction by 2. So that would give me 9/12 and 10/12. So that would be 19/12. We can't cross-reduce or anything like that, so we get 19/24. Turns out, hey, that's a weird number, right? 19/24 is midway between 3/4 and 5/6. Let's see that again. All right, what is halfway between 5/9 and 4/7? The technique is we add the two fractions and multiply by 1/2 or divide by 2. Okay, so let's see. Common denominator would be what? 63. So the first fraction, top and bottom by 7. Second fraction, top and bottom by 9. See what I did there? Pause the video. Wrap your head around what I just did. I just got common denominators. 35 and 36 is 71. And then I multiply by 1/2. That would be 71. Remember, multiply straight across. 71 times 126. That's really weird, right? But 71 over 126 is halfway between 5/9 and 4/7. Does this work with negative? It sure does. You just add negatives. Okay, so go ahead and pause the video. Do this one by yourself, and then answer the question on Google Forms, and then play the video to check your answer. How'd you do? All right, so the techniques, we add the two fractions. Common denominator here obviously is 50, so I just need to change the first fraction to what, 8 over 50? And it should be negative 8 over 50. Negative 8 plus negative 9 is negative 17 over 50. Multiply by 1/2, we get negative 17 over 100. Negative 17 over 100 is halfway between negative 4/25 and negative 9/50. Crazy, right? All right, so there is the class. That'll do it for today. If you have any questions, and please, for the 3 or 4 of you that did poorly, send me an email and ask for a reteach and a retake. One person already did, and they got an A. All right. Okay, so I'll see you guys on Friday.